So let us look into this. So this is called simplified architecture of SAP HANA. So the reason why, as I told you, that basically there will be one more architecture called service level architectures, which we are going to discuss in a separate session. So once after your installation is completed, so then we are going to look at those services and the significance of each and every service. We'll come to that later on, but now just let us focus on this simple architecture what SAP has given here. So if you look at this architecture diagram, so basically you can separate this architecture into three separate areas, mainly three separate areas. So yeah. It's not showing. Okay. See here we have something called external interfaces, and then we have that request processing and execution control, as well as storage in the memory, processing as well as storage in the memory. And there is one more area here called disk storage, which we also call it as persistent storage. So like this we can separate or segregate this into three areas, so as far as this architecture is concerned. Now let us look at this storage, how it happens and how these storages are handled by SAP in the HANA database. So if you remember that, as I told you earlier many times, in SAP HANA, never assume that data will be stored only in the memory, because if you store the data only in the memory, and in case if your system goes down for any reasons, so there's no possibility of getting the data back. So to keep the data safe, they need to also store the data in the disk, so which we call it as persistent storage. So that persistent storage is nothing but storage of the data in the disk. That's what they're given at the bottom of the screen. Here you can see the disk storage. So if you observe there, disk storage, the persistent storage is separated into two areas, two parts. One we call it as data volumes, another one is log volumes. So two areas of disk storage you'll be having. So at the time of installation, we'll allocate the path for that, and we'll allocate some specific spaces. Okay, this much of the size of that storage should be how much. So anyhow, that how much it should be for data volumes, what should be the size of log volumes, that we'll be learning when we go for sizing in detailed discussion. After this architecture, we are going to get into that sizing right away. But one simple point you remember as of now, this data volume size will be always bigger, and that keeps on growing as time goes on. As the volume of data increases, the data volume size keeps on increasing, but not the case when it comes to log volumes. Log volumes will be always that almost fixed size you'll be having, and that size is going to be very, very small if you compare with the data volumes. So why is it so? You'll be knowing about that shortly. So to understand that persistent storage in a better way, let us look at this diagram. And that portion only, we just separated a portion of it. The bottom half of that is separated here. So you can see this. This is a persistent storage. Yes, this is diagrammatically, it's clearly shown that data volumes are bigger in size, log volumes are smaller, and the data will be always written from the memory to the disk. It's compulsory, it's mandatory. If you don't write the data into the disk, you'll be losing that information. So that's why it will keep on writing the data into the disk. So how it happens, how frequently it happens. First, let us look at these data volumes. So data from the memory, at regular intervals, it will keep on writing the data into these data volumes. So those regular intervals, what we call them as save points. There will be regular automatic save points. Means in regular intervals, it will keep on writing the data into these data volumes from the memory. So how frequently that happens? There is a save point interval which is defined by SAP, which is default 5 minutes. You can see on the left side here, at least every 5 minutes the data will be written into this data volume. So that regular save points, what we are speaking about, that save point interval we can define if you want, means we can customize that. Instead of 5 minutes, you want to modify it to something else, we can do it, which is not recommended because there will be some configuration parameters which we don't suggest to modify. SAP has given some optimum values. So it's better to go with those optimum values instead of doing some changes unless otherwise we know clearly how your database is running, unless otherwise you know how the performance impacts are there. It will be very, very complicated for you if you modify some of the parameters. Anyhow, it's not recommended, but it's customizable parameter. SAP is giving that flexibility for you to modify. So don't worry about that customization part. Leave it aside. Now, we are saying that every 5 minutes data will be written into data volumes. Suppose 5 minutes back data is written into data volumes. Now again it's writing the data. What it will do is whatever the changes happen, that will be written. Change data, undo log is written from the memory to the persistent storage. So how system will identify it? It will generally, there will be concept called data pages, just like our pages in the book. Suppose that particular page is modified, those changes will be written into this data volume. So the changed data pages will be written into the data volumes regularly. Changed data pages or modified data pages will be written into data volumes. So that basically will be taken care by this page management. This page management will take care of writing the data from the memory into the disk. The other way also, from the disk to memory also, it will load the data. Okay, so that happens every 5 minutes. Now, suppose when you are saying that every 5 minutes data is written into the data volumes, say example 5 minutes back or maybe 3 minutes back a save point interval occurred. So 3 minutes back data was successfully written into data volumes, but last 3 minutes also some transactions taking place. So in the last 3 minutes when transactions taking place, even that information is also very crucial for us. We can't just leave the data like this. Say example, assume that you are not taking care of that last 3 minutes transactions or 4 minutes transactions. By chance your system is down. When you restart your database, data volumes are consisting of the data till the last save point. Data volumes doesn't have the data after the save point because that's how it will be. So they will be bigger in size, the data volumes will be bigger in size. So writing the data into the data volumes is not recommended to frequently. We can't try to update data volumes for every single committed transaction. It's not at all recommended because that is really big. It's really big. So that's why they don't want to update the data volumes for every committed transaction. So to handle this, the new transactions you're doing, some updations you're doing after the last save point occurred, till the next save point occurs. So SAP has given these log volumes for you. So in the log volumes, what we do is, what we store is, we'll store information about data changes, any redo logs we have. So what happens is whenever you do a transaction, suppose you created a sales order or you created a customer, you created a material, any transaction like that, whenever your transaction is committed, the data will be written into log volumes. Every single committed transaction, and more importantly, writing the data from the memory to the data volumes is an asynchronous process, whereas writing the data from memory into the log volumes is a synchronous process. So that you can see in this first diagram itself. Here you can see data volumes, writing the data into data volumes is asynchronous, and this is synchronous process. Why is it so? It's a clear meaning is there. So when the data changed, the data pages which you have changed, you are writing into the data volumes, obviously it's a time taking process because 5 minutes, a lot of changes you might have done, a lot of transactions are completed. So you can't make the end users to wait until all that is written into your data volumes. That's why obviously there in such situations you go with asynchronous process. But whereas when it comes to writing the data into the log volumes, particularly your redo logs, any new transaction is done or performed, we have to make sure that the transaction data is properly persisted. In case if you're not looking at that, I mean if you're not making sure the data is written into the disk, so by chance your system is done after the committing is completed before writing the data into the disk, you're losing that information. So that's why to avoid those kind of situations, what they did is writing the data from the memory into the log volumes. They made it synchronous. What's the meaning of that? Suppose as an end user, you are creating a new sales order using some graphical screens. Whenever that sales order you enter the data, click on the save button, and when you confirm that, first data will be written into the memory. There will be some buffers in the memory. So first into that buffers, we call them as log buffers. It will write the data into that buffer, and from there it will be writing into the log volumes. Log volumes also files only. So we call them as actually log segment files. So it will write the data into that log segment files, and then a response, a message will be given to the end user saying that your transaction is completed. Means end user has to wait until the data is written into the disk. Without writing into the data into the disk, end user won't get any message saying that transaction completed. So basically we are making sure that your transaction is persisted, transaction data is persisted properly there. That's so crucial. So that later on whenever your system goes down for any reasons, when you restart your database, you'll get data from your data volumes, and after your last save point, what are the transactions you did, all that information will be available in log volumes. But you know, when we speak about this, writing the data into the disk, and that too we are saying it's a synchronous process, obviously generally the doubt will be there. It looks like normal RDBMS, performance will, impact will be there. Definitely you have to compromise on that, because uh, you know, if you don't wait until the data is written into the disk and then you give a message, if anything goes wrong in between before writing the data into the disk, you know, the end user will get a message saying that your transaction completed if it's not a synchronous process. But whereas your data is not written into the disk, if something goes wrong and system is down at that point, when you restart your database, you won't find that data. So that leads to a lot of data inconsistencies. That's why to make sure that data is consistent, making that writing data into the log volumes is a synchronous process. But to make it effective, to reduce the time taken, what SAP is highly recommending is, it's recommending all the customers. It's not obligation, it's not mandatory. SAP is highly recommending that for log volumes, which are smaller in size, it's not so big, it's smaller in size. So log volumes, it's always better to go with SSDs. You might have heard about solid state drives. SAP is highly recommended to go with solid state drives, which is the best option there, because you might have heard about SSDs. Even some of the laptops nowadays also you see that solid state drives. So you know, hard drives went through a lot of changes. Like you used to use IDEs initially, then SATA. Now you have these SSDs. SSDs will have high disk IO. I mean, input output read write options. It will be very faster when you compare with normal hard drives. So if you can use SSDs there, the time taken we can reduce, and we can make the transactions more efficient. So we can also suggest for the data volumes, but you know, data volume size gradually increases. So that becomes more expensive for the customers. If the customers can afford, we can also suggest SSDs for data volumes. But as of now, stick to the log volumes, which are smaller in size. Generally, here comes the question, what will be the size of data volumes, what will be the size of log volumes? I mean, when we go for sizing, I told you we'll discuss in detailed way, but just for temporarily information you remember. Usually, followed sizing is data volume size will be 3 times of RAM. And the standard approach, in appliance approach, data volumes will be 3 times of RAM, whereas log volumes is equal to RAM. So this is only one time of RAM, that is 3 times of RAM. But when we say log volumes equal to RAM, that's not needed that much when your the HANA appliance is having a very big size memories. Suppose my HANA database I want to have with say 4 TB. I don't need 4 TB for log volumes. It's not compulsory. So the basic logic what you need to understand there is, if my log volumes, that storage, can store the data from one save point to another save point, enough. That's it. Only that much of data it has to hold. So from one save point to another save point means that's a 5 minutes time. 5 minutes time, how much? You'll have an idea in the company, generally the kind of business they are doing. Based on that, we'll have an assumptions. Okay, 5 minutes, how many transactions they'll do, how many data changes they perform, what will be the volume of that. So generally, we don't recommend anything beyond 512 GB for log volumes. Even your RAM is 2 TB, 3 TB, 4 TB is also log volumes. We recommend 512 GB. Ideally, nothing more than that. So other way, if anyone asks you what should be the optimal size of the log volumes, don't give numbers. Instead of that, you can just tell them that the best way of identifying log volumes is basically the size of the log volume should be equal to the data, size of the data from one save point to another save point. What are the data changes you're doing, or new records, new transactions you're doing. It should be capable of storing data from one save point to another save point. That's it. If that is there, that's enough. So this you don't worry. There is one point they given here, cyclic override. What is that override and why they do it? What is the need of doing it and all that? Only when we go for backups you can understand, not now. Because backup mechanisms are so crucial in SAP HANA. It plays a very important role to run your database in a better way. Okay, so that's how basically the data will be written from the memory into your the disk. Same way, see, whenever we restart the database, now data is available in the disk. When I restart my database, when database is shut down or maybe down for any reasons, there is nothing in the memory. Memory is just purely volatile. You won't find anything in the memory. So whenever you restart your database, so it has to load the data from your disk to the memory, or from persistent storage to the memory. It has to load the data. But here comes a doubt. Suppose my database size is very big. If it has to load this entire data from the disk to memory, obviously it's time taking. It has to load the data from data volumes, log volumes, make the database start, and then make it available for the end users. Obviously time taking. As the volume of data increases, the time taken for starting the database will increase drastically. So is it really meaningful to make the end users to wait until the entire data from the data storage, that is your disk, to the memory? Is it really meaningful? Does it make any sense? And that we need to think about. So just imagine any company, say there are 100 employees working. Just before shutdown of your database, for any reasons, say assume that there are 10 users working at that time. So 10 users are accessing some tables, they're doing some manipulations, some updations, whatever it is. So there are 10 people accessing the database and doing some transactions at that time. So when you restart your database, if you make these users to wait until the entire data is loaded, which may take 5 minutes, 10 minutes, depending on the volume of data, even if they wait and once your database is started up 10 minutes, can you imagine these people using the entire data, whatever you loaded into memory? The simple answer is no. No way they are going to access this entire data after your database is restarted. No way. No possibility at all. So when they are not going to access this entire data once our database is restarted, what's the point in making them to wait until this total data is loaded into the memory and then database is started, then making the database accessible to them? So that definitely is a problem. So that's the reason why what SAP has done is they came up with a strategy there to reduce the time taken to start your databases. At the same time, you need to think about the performance also. You need to balance them both effectively. Because see, without loading the data into the memory also, I can start the database without loading any data into the memory. So without loading the data in any data into the memory, if I start my database, when the end user is trying to access, for every time, say suppose user 1 is accessing some table 1, whenever he accesses the table first time, it has to load from the disk to the memory and then should be presented to him. Obviously, as it has to be loaded from the disk to the memory, there will be time taking. So he can feel that performance difference very first time. After that, it won't happen because next time onwards, whenever he's trying to access the same table, already we have the table data in the memory. So it will access from the memory and present it. So he'll feel the performance is normal when data is there in the memory. But first time when he's trying to access, he can really feel the difference because it has to load the data from disk to memory. To avoid and handle these situations carefully and effectively, what SAP has done is they came up with a mechanism called lazy load. Lazy load. So that lazy load mechanism they implemented in HANA database, which is default. And some of these lazy load techniques we implement by doing some small configuration settings. Small settings will do wherever it's needed. But in general, that lazy load mechanism is implemented by SAP default in this. A lot of techniques will be there in that. Some of the techniques are default in that. So what is that lazy load mechanism? This is applied by the database automatically whenever you restart your database. So whenever you restart your database for any reasons, as we know that the entire database, entire data is not going to access it by the end users. So instead of doing loading of this entire data into the memory, what it will do is, first of all, whenever your database is restarted, first it will load only the tables which are required to operate your database, to run the database. You know, whenever you want to run your database without any application data, first and foremost thing you need is you be having something called system tables. So without system tables, your database doesn't run. System tables are the ones using which basically your information about your database, how it should run, you know, that management system, all that depends on those tables. So system tables are so crucial. So first of all, it will load the system tables into the memory, which are needed to operate and run your database. And then after system tables are loaded, then there is a mechanism because of which it can identify it. It's having such a kind of intelligence with a small setting, with a very small setting, configuration setting. If you can do, system is having such an intelligence. It can identify the tables which were being accessed by the end users before shutdown of the database. That information is recorded. It can remember, okay, these are the tables which were being accessed by the end users when such system is shut down. So immediately what it will do is those tables which were being accessed by these end users before shutdown, those tables will be loaded into memory because there is a maximum possibility of continuing these operations by the end users immediately once database is available. It's quite natural they do it because when I'm working suddenly something goes down. Once system is up, I'll try to continue that activity. It's quite natural it happens. So that's the reason why they built a mechanism they have such an intelligence mechanism which can identify the tables which were being accessed before shutdown of the database and making those tables available in the memory immediately after your system tables are loaded, so that it will take care of. So that those people won't feel any difference, like once database is started, whenever they try to access the tables, they will come from the memory. Obviously, they won't feel any performance differences. Now, apart from that, suppose if I know as an administrator, if I clearly know that, okay, these set of tables are going to be accessed by the end users frequently. I know, okay, there are 10 tables, 15 tables, which are definitely going to be accessed by the end users. It's guaranteed. But maybe before shutdown of the database, they are not accessing them. But there is a possibility of these tables accessed by the end users regularly. So when I have that information as an administrator, what I can do is for those tables, exclusively for those tables, I can do a simple setting with a simple SQL statement. I can do a setting to load those tables. Once I do that settings to load the tables, for whichever the tables I did that load setting, irrespective of whether the end user is accessing them or not, whenever your database is restarted, these tables also will be loaded into memory. But you need to do it carefully, because the bigger number of tables, the time taken or the duration to restart your database will increase. So then end user has to wait for more time to access the database. So though we need to balance these activities, we cannot blindly follow one thing always. So that facility also they're given for you. Suppose assume that I've restarted the database. At that time there was no settings done like this, but after the database is restarted, I came to know that okay, these tables are going to be accessed by the end users, but not regularly, but at that point of time there's definitely a possibility and they're going to do access them. So if I don't want to make the end users to feel that performance differences, manually also I can do. As an administrator, I have a facility to load those tables manually into the memory. I can just go to the table and choose that load option. It will be loaded into the memory. So that flexibility also we have. So these things you can take care of, which are part and parcel of your lazy load. Some of them will be done automatically. Some of them will be done with the simple configuration settings. Some of them we can do manually also if needed. But suppose, okay, this is all part of it. Suppose assume that the table is not accessed, no configuration settings done for the table. The table is not loaded into memory. So the end user is trying to access the table very first time after the database is restarted. Because there were no settings for that, the table will be loaded into memory from the disk first. Whenever the end user is trying to access, it will be loaded from the memory into the disk. I mean disk into the memory. Okay. So definitely there is a little bit of time taking process. But to reduce the time taken to load the data from the disk to the memory for that particular table, whichever the end user is trying to access. So there is a mechanism actually, because of this specialized storage mechanism we have in SAP Hana. At that time also they can reduce, because generally what happens, in general you think if at all if that user is accessing the table, he's not going to access the entire table most of the times. Particularly when you speak about analytics, any analytics in the world you take, only less than 10% of the database columns are used for analysis. Less than 10% of the database columns. So when we say less than 10% of the columns are used for analysis, if end user is trying to access a table, if he is trying to execute a report, a query on a table, there's no point in loading the entire table into the memory. That's what the problem will be having if you go with your traditional storage. You know, the traditional storage when I'm referring to that row store which you find in any RDBMS. In RDBMS, Database tables, the storage will be row stored. Data is stored row-wise. So the drawback we have there is whatever columns I'm accessing, irrespective of that, everything need to be loaded into memory. So SAP HANA database supports that. It definitely supports row store. But the problem is as it has to load entire table into the memory, obviously time taken will be more, which is not actually required, where the customer needs only 10 columns out of 100 columns. So that's why to avoid these kind of situations, to have the better performances when you're reading the data, and you have to have better performances while you're writing the data, to have more data compressions to cut down the cost. For all that, what SAP has done is SAP came up with the column store. So if your table is a column store table, if you try to access the data from the table, the specialty you'll be having in column store is if you request for 5 columns out of 50 columns, only 5 columns will be loaded into memory. It won't load 50 columns into the memory, only 5 columns will be loaded into memory. So obviously you can see the clear difference, the time difference between loading 50 columns and loading 5 columns. So loading 5 columns obviously will take little time. So we can reduce the time taken to make the data accessible to the end users. In that way, we can improve the performances. It's also one of the most important technique. Apart from all those lazy load techniques, what I told you, in case if a table is not available in the memory, so this also plays a vital role because the column store gives always that special advantage for you. So that's why you find all your application tables in your HANA database as column store tables only. All the application tables. Even they replicate the tables from some source systems into HANA, as I explained your earlier session in landscape architecture of HANA as a warehousing solution. Like when they load data, replicate tables from ERP or any non-SAP systems into HANA, all the replicated tables will be column store tables only. Specialty in column store tables are both, they are read optimized as well as write optimized. And even bigger one, the most important one is the high compressions, because of which the storage space required will be little and you can cut down the cost, particularly the memory. Okay, so these are all, whatever I told you, all these are part and parcel of your lazy load mechanisms. So we'll also have that information, like I want to know whether my entire table is loaded into memory or not, all that I can find out. Okay, once after your installation is done, we can have a look into that in detail, but just observe. So suppose this is my table, this is my table definition, which is a column store table. If I go to runtime information here, I can find what's the memory consumed by that. Okay, additions also we did here intentionally, and here you can see loaded. On the right extreme corner, you can see the last column is showing loaded true. Everything. So they access different records and all that. That's why it's showing separately. But now, suppose if I don't want, this table is not being used by the end users, I want to unload from the memory. See all these memory consumptions, what is showing, that will go off. There's nothing memory consumption, total memory consumption, nothing is showing. Number of entries and size on the disk only. But now you see these columns here, false. If someone access this table, now immediately it will load those accessed columns. Yes, there will be different people working on this. Let me try. If no one is accessing, that will be good. Otherwise, I cannot assure. Select. only two columns. It's taking time to update this information. Will wait. See here, you can see that now no memory consumption it will show you, which was not showing earlier. So such a kind of mechanisms they've introduced, which will allow you to make the database accessible to the end users in a short time period, as short as possible, to keep the downtime short, particularly when your database restarts for any reasons. So you can utilize this, which is part and parcel of your default mechanisms itself. And as I told you, some of those settings we need to perform sometimes. So those we call them as basically configuration settings. Learning how to do those things. So there will be some special configuration settings. This one and this one also. Reload tables, if you set that true, and automatically that system will recognize which were the tables being accessed before shutdown of the database, and automatically they will be loaded into the memory. So that intelligence and all that we have. So this is a continuous activity from memory to the disk to the disk to the memories. That's why we have to make sure that what are the storage solutions we offer are also efficient. So you need to take care of the storage solutions also very carefully. Again, some of the situations SAP will give you the flexibility of choosing your own storage solutions, but those storage solutions must be certified ones. So SAP is giving the list of certified storage solutions which you can opt for. You know, generally in the companies we use that the storage area networks, and now newly we are using that NAS, network attached storages, which are very popular now. So that you have to use, because your storage is not properly maintained. If it's not certified one, there comes again the performance issues. So that also you need to be really careful. And as is recommended, log volumes, we suggest always to go with SSD hard drives. So that also generally they mention in your sizing process when you follow. See SSDs for log volumes. Data volumes I suggest, but it's very expensive. SSDs for smaller ones you can go for data volumes, but bigger ones it's not too easy for the customers because it's going to be expensive for them. Still, it's not yet updated. Is that clear now? So only the one portion of it, what we have discussed, only the data writing from the memory into the disk and loading from disk to memory. That's it. Only these couple of things which you have discussed about. But we need to understand if a request has to come from an end user, how the end user will send a request. End user has to send a request from an interface. He may use different kind of interfaces. Someone may execute the report, someone may execute the transactions. Those transactions they may perform by using different applications, or maybe web interfaces, web applications they may use, depends. So if they want to do a transaction from that interface, if they want to connect to the HANA database, what exactly happens in the database and how that processing will be performed, and then how your database will be updated. So all that you need to understand, that's the detailed mechanism we have in that interfaces, as well as in request processing and execution controls, which we are going to look at. I'll explain you those things also. So only this persistence part, if you have any doubts, tell me. Okay, so have a look at that. This is there in the document. There is a document with name HA200. So if you can go to the document HA200, you can refer to this architecture. The same thing is explained with the same diagrams. Just start looking at that particular document for technical information. Okay, in tomorrow's session, we'll look at these interfaces as well as the request processing and execution control, this part. What is this and how the processing takes place. Documents, you just send a